Okay, hi everyone. We're going to do this question here about the 60 watt 120 volt light globe. We're asked to find the resistance of this resistor here. So we're going to have to use a couple of pieces of information. We're going to use the relationship of P equals VI, which will enable us to determine the current that is being used. We are also going to use the fact that we know from Kirchhoff's law, if 240 volts are being supplied and 120 volts are being used up across this light globe, then that means there has to be 120 volts being used up across the resistor. So once we have both the voltage and the current, we can then use V equals IR to calculate the resistance. So let's start. First off with the piece of information that we know. We need to know current, so let's rearrange for current first. Then substitute in. We've got 60 watts divided by 120. And that's going to give us our current. Bring the calculator over. 60 divided by 120. That gives us 0.5. amp. We now need to calculate for resistance. That's going to give us V divided by I. That's 120 divided by 0.5. And that's going to give us 240. So 240 ohms is the resistance required. Okay, so we now come to this Christmas tree lights problem, where we're given quite a bit of information, and in particular it can be a little bit bamboozling with all the information that we're given and the diagram. Again, we've really got to remember that we're just using Kirchhoff's laws, and V equals IR and P equals VI. So we know we've got 16 globes here in this group P, and we're told that they're 10 volts each, which means the total voltage across this section here is going to be 10 times 16, which is 160 volts. So we know that we've got 160 volts across that section. Now, using Kirchhoff's laws, if we have 240 volts in total and 160 across there, then what is across this section here must be the remainder. So 240 minus 160 gives us 80 volts. So we know we have 80 volts across this section here. Now, don't be frightened to annotate the diagram. It's actually really important to show you're recognizing and understanding what's going on. So marks like annotations of the diagram help the examiner understand your thinking. Next thing we need to do is then work out, well, how many globes would this be? If the globes are still 10 volts each, then that's just going to be 80 divided by 10, 8 globes are going to be required. Eight globes. Then the next question that we need to do is, what is the current being supplied from the electricity supply to the string of lights? Okay, so we know that we have 0.5 volts going through here, and we know that it's going to come in through here and split, but come back together here. So really, there isn't much calculation required for this problem. If you understand the way that it works, then there's going to be 0.5 flowing through all of here. It'll get split, but then come back again. So the actual supply current is still going to be 0.5 of an amp. Okay, so the next part asks us to calculate the power rating on one of the globes in the QR section. Now remember, we just discussed that the current is going to be 0.5, and it's going to split when it goes down this section here. Now, as we know, we have the same number of globes on both sides, so we know the split is going to be half and half, and you're using that piece of information to actually then do this calculation. So this question is assuming that you recognize that the current is going to split when it goes through that section there. So starting with our understanding that the current in that section Q or R is going to be equal to 0.25 of an amp, and then we know power is equal to VI. We're told that the voltage is 10, so it's going to be 10 times 0.25, which is going to give us 2.5 watts. And that's really all we have to do. Now the last question, indicate in the box each side whether the globes in the group are on or off. If the group is on, indicate whether the globe is brighter or dimmer compared to the system operating normally. Okay, so this last question asks us to identify what happens when globe Q burns out. So a globe in Q is going to break this part of the circuit here. So what's going to happen with P? Well, P will still be on because our current can still go around this side and come back in. So that's still going to be on, and it's going to be dimmer. Now, why is it going to be dimmer? What you need to remember is when you have two resistances in parallel, their overall resistance is actually reduced. So when we then lose this side, it means that this resistance is going to be larger. Remember, it's actually going to double, which means that the total voltage is going to be larger across this section, so it'll be smaller across this section, so this section will actually become dimmer. The next one, Q, is going to be off. Okay, and there's really nothing to write here because they're all off. And then in R, they're going to be on, but because their total resistance has increased, which means the voltage drop across R is going to be larger, this is actually going to end up being brighter.